Never before has a comet been seen in such extraordinary detail or studied more closely. And now the next stage of the Rosetta mission is underway. The spacecraft is no longer orbiting Comet 67P Churyumov-Gerasemenko because of its activity. Instead, it's performing flybys, and one brought Rosetta to its closest ever encounter, just 6 kilometers from the surface.
What we will be doing will be alternating far flybys, so maybe 50 kilometers or so with relatively low speed, with close flybys with higher speed. And with this different flight condition, we will hope to be able to explore completely the environment of the comet.
The Rosetta orbiter's maneuvers are controlled here at the Planetary Missions Control Room in ESA's European Space Operations Centre at Darmstadt in Germany. We already know a lot about the comet, including the exact signature of hydrogen present in its water, which indicated it was not the same as water on Earth. The flybys allow Rosetta to continue taking measurements up close, with the aim of further understanding the surface of the comet nucleus, the exact types of organic material on the comet, and by studying how different wavelength light reflects from the surface, the dust grains. Insight will also be gained about the comet's atmosphere or coma.
We're looking at where the gas and the dust start to accelerate from the surface and how that beginning of the coma, that birth of the coma works. So how the coma develops as it does to higher altitudes. This region has only ever been theoretically constrained or modelled. These will be the first measurements we make in this area or this region, and that's a really big, important target for us.
During the next few months, Rosetta will examine how the nucleus activity increases to a maximum shortly after perihelion in August, its closest distance to the Sun. Rosetta will then measure how the activity wanes to give the fullest picture yet of a comet's activity cycle. Even the unexpected series of bounces after Philae's descent and landing in November had a positive side, as uniquely they gave scientists multiple points of data from different parts of the comet's surface. Philae is currently in hibernation, its whereabouts unknown. But we know from this image that Philae is in the shadow of what resembles a cliff or rocky overhang. As the comet gets closer to the Sun, there's a slim chance its solar panels could gain enough power to reactivate.
Having Philae reactivated is not so likely, but it's not impossible. Philae was designed to hibernate, was designed to switch off and be able to reactivate itself. Of course, we expected this to be a duration of a few days or a few weeks, not a few months. But okay, we will see. Maybe we are lucky and the units have survived these months and will reactivate in June, July.
Future flybys will try to pinpoint the lander's exact location, but this year the science focus is all about the orbiter. The flybys, 2 a month at distances from the comet ranging from 15 to 250 kilometers, will allow the nucleus to be studied at different resolutions. Rosetta will also be able to observe how the coma interacts with the solar wind. So far, Rosetta has only mapped about 70% of the surface because the comet's orbit and rotation kept certain areas in darkness. This year, new regions will come into view, alongside new activity on the surface. And in the summer, the orbiter will be in a unique position. The comet will be at the peak of its activity, and Rosetta will have a ringside seat.